previously, what we did was we calculated or determined what the empirical formula for vitamin C would be. Now, I'm going to tell you that we've performed some mass spectrometric experiment analysis on a sample of vitamin C. And remember that a mass spectrometer will tell us what the molar mass of the compound will be, provided we perform the experiment correctly using the right mode. And so in this case, we find that the molar mass is 176 grams per mole for vitamin C. So we found it to be 176. So we know what the molar mass should be for the compound. We want to determine whether this is truly that formula that corresponds to that. And I think that what you're going to find upon looking at it is that that indeed is not the formula. We're going to have to determine what the formula will be. And it's not going to be a hard process to do that. But we're going to need to know two things. First, we're going to look at this ratio. The ratio of the molecular mass, the molar mass of the compound, to the empirical mass, which is going to be the mass of the formula that we determined in the empirical formula calculation process. So what we've done is we've already determined by mass spectrometry what the molar mass of that compound will be, and it is 176 grams per mole. What we want to know now is the empirical mass. So we need to determine what the molar mass of this compound is. So we're going to take 3 times the atomic mass of carbon, 12.01, and we're going to take 4 times the atomic mass of hydrogen, which is 1.01, and we're going to take 3 times the atomic mass of oxygen, which is 16. Add them all together, same way that we would do any other molar mass calculation, except we're doing it on the empirical formula now, and we end up with 88.07 grams per mole. Sometimes you'll see that as Daltons, or there are some other units for them, but essentially it's just the number of grams in a mole. And so that's our empirical mass, 88.07 grams per mole. So you see the units are going to cross out. They're going to leave it with this unitless ratio, just a magical ratio that we're talking about now. It's a ratio of how many empirical units need to be added together to make one of our molecular units. To make one of our molecular units. So if you do this division, you're going to find that that number comes out to pretty close to 2. So our ratio is 2, and what that 2 means is that we're going to multiply 2 by each of those coefficients, those subscripts in the formula. So instead of C3, we have C6. Instead of H4, we have H8. And instead of O3, we have O6. And so what we've done is we have gone from the empirical formula, which is C3H4O3, by using the empirical and the molecular mass that we got from a mass spectrometry experiment, we can calculate this ratio, and then the ratio is what we're going to multiply by each of the subscripts in that empirical formula to get the molecular formula. Sometimes it's 1. It's always going to be a whole number if you've done the calculation correctly, and so that way you can figure out what the molecular formula might be for some compound that you're not quite sure what it is.